Hey, go ahead and put your name on here since everybody's looks the same. And I will have you guys turn this in with your test in case we do like corrections or have to finish them or something. All right, we're going to go through each section. Depending on the section depends on how much stuff we put about it. So 4.1, domain and range. Domain was all of your x values. For domain, we are going from left to right. And range, we are going from bottom to top. It's all of your y values. Okay. Looking at our two graphs here, we are going to find domain and range for both of them. If you guys notice there's only one blank, we taught you interval notation and inequality notation. We are only having you do interval notation on the test. We're only having you do inequality notation on the test. They both start with an I, sorry. We wanted to teach you both because it's important that you know both, but we're not going to test you on both because that's just a lot of little details to grade. Also on the test, it's matching. You're welcome. Okay. So, domain for this first graph. The furthest left thing on this graph is an arrow. So my domain starts at negative infinity. With infinities, I always use less than symbols. And with domain, I always use x's. So I've got negative infinity is less than x, is less than or equal to, the furthest to the right my graph goes is 3. So negative infinity is less than x, is less than or equal to 3, is my left to right. Okay, range is bottom to top. So bottom of our graph is an arrow, top of our graph is an arrow. So bottom to top is negative infinity to positive infinity. So negative infinity is less than x, made a mistake. What should that be?
Wait, no, y.
Y, because it is my range. And my whiteout just broke. Okay, change that to a y. Is less than positive infinity. Whiteout doesn't really work on blue paper. I need blue out, but I don't have that. So negative infinity is less than y is less than positive infinity. Let me zoom into those guys. Okay, so left to right is negative infinity to 3. Bottom to top is negative infinity to positive infinity. Okay. My next guy is a little hexagon. From left to right, I go from negative 3 to positive 3. So my domain is negative 3 is less than or equal to x is less than or equal to positive 3. Because they are numbers, that's why I use the less than or equal to signs on both sides. Then for range, bottom to top, the lowest my graph goes is negative 2 right there. And the highest my graph goes is positive 4. So negative 2 is less than or equal to y is less than or equal to 4. Okay, I'm going to change how I said this. I said it's matching on your test. It's not matching. We give you an answer bank. So there's 4 graphs. We give you 4 domains and 4 ranges. So you can use process of elimination to use your answer bank. And then your answer bank also has the correct less thans in it and less than or equal tos. So make sure that you use the answers from the answer bank. Okay, every year I have someone try to just do it on their own and not use the answer bank and get something wrong. Any questions about domain and range? Okay, next thing we have then is 4.2, which was functions and relations. To be a function, each x value has to have only one y value. For a table in ordered pairs, we checked for repeated x values that led to different y values. And for the graphs, we use the vertical line test. To be a function, a vertical line can only cross the graph once. So that is what you need to do for functions and relations. and you've got examples on your review. We did not put any examples on here. If you need to squeeze in some examples, you can, but we did not put any examples on here. Okay, 4.3 and 4.4. 4.3, we were evaluating functions from an equation. So we substituted in a number for x and solve. I will have you guys grab calculators in a second. Let's do this without them. Sorry, I forgot to take the calculator sign down today. So we want to find f of -3. So we're going to plug in -3 for x there. So instead of 4x squared, it'll be 4 times -3 squared plus 5. To solve this out, what would be the next thing I would need to do? So do the -3 squared. So -3 squared, which means -3 times -3. Negative times negative is positive. That's going to be 4 times 9 plus 5. So exponents come next. Then multiplication. 4 times 9 is 36 plus 5. And then 36 plus 5 is 41. Addition and subtraction comes last. You guys will have and can use your calculators. I will have you guys grab those here in a second. Hey, and then evaluating functions from a graph. We put a little description of what you need to do here. You go to the x value that you are evaluating at, and then you go straight up or down to find the corresponding y value. So we're giving you the x, you find the y. And then this is also where we did maximums and minimums. Your maximum would be a high y value, your minimum would be a low y value. Again, if you need examples of those, you'll have to squeeze them in. If you want to draw a little picture of what a max and min looks like. Any questions right now? Okay, go ahead and flip this over then. Got 3 more sections on the back. Go ahead. Hey, 4.5 was function attributes. 4.5 on the test is matching. So 4.1, you have an answer blank. 4.5 is matching. For increasing, we are looking for when our y values are increasing when reading from left to right. For decreasing, we're looking at when our y values are decreasing when reading from left to right. Your x-intercepts are points at which you cross the x-axis. Your y-intercepts are points at which you cross the y-axis. Then we also have maxes and mins on these, but I have the definition of that on the front of the note card from 4.4. So, looking at these guys, I like to do my labeling. So I'm going to draw a vertical line where I switch, and then I'm going to start labeling things. On the left side of my graph here, actually, I'm going to label up above just because I don't have enough space down here. So on the left side of my graph, it's negative infinity. On the right side of my graph, it's positive infinity. I'm going up, 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 and then I switch here at -3, and then I start going down, 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 down. This is the exact same labeling I did. I'm just doing it above my graph instead of below my graph just because there's not enough space down here. So from negative infinity to -3, I'm going up, 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 up. So I am increasing. And then from -3 to positive infinity, I'm going down, 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 down. So I am decreasing. So once you get that, you can then label your graph so then you can just put it on your blanks. So I'm increasing from negative infinity to -3. And then I'm decreasing from -3 to positive infinity. Okay. Does this graph have a high point or a low point? A high point, is that a max or a min? Maximum. So you guys can circle maximum. It has a maximum right here at y equals 3. All right. Next one. My next graph is going down and then up. So it is decreasing and then increasing. This is negative infinity. This is positive infinity. And the point where I switch is 3 this time. So I start by decreasing, and then I start increasing. So we are decreasing from negative infinity to 3. And then we are increasing from 3 up to positive infinity. Okay. This graph has a low point. Where is that low point? 2. So it's got a minimum at y equals 2. Okay. I did not have space to add on intercepts here. If you want to add it on in the margins, if that's something that's going to help you, you are more than welcome to. Any questions about attributes? All right. Then let's talk about 4.6 and 7, transformations, and then we will get you guys started on your reviews. So first thing that we need to do is fill out this table and make sure we get it filled out correctly. When we add inside a function, that moves us to the left. When we subtract inside a function, that moves us to the right. When we add outside a function, that moves us up. And when we subtract outside a function, that moves us down. Okay, then the last thing that we put on here is 2 empty graphs for us to put both of our parent functions on. So your parent function for a quadratic, start at 0, 0. And then we have a point at 1, 1, because 1 squared is 1. And then we have a point at 2, 4, because 2 squared is 4. Then we go the other side, we have a point at negative 1, 1, because negative 1 squared is 1. And then we have a point at negative 2, 4, because negative 2 squared is positive 4. Those are our 5 points that we need to know where they go. So once we get them moved, we can make them the correct distance from each other. And then you can connect them. Okay, and then the last thing we have is our absolute value graph. Absolute value is the distance from 0. So 0 is 0 away from 0, 1 is 1 away, and 2 is 2 away. Then, on the other side, negative 1 is 1 away, and negative 2 is 2 away. So those are our 5 points there. And those connect into a little V. Okay. I am going to go ahead and stop this video. Does anyone have any questions right now on anything on the note card?